Have you ever wondered how big the universe is? How many stars are there? Does space go on forever? The answer depends on the shape of space. Let's explore some possibilities. There's an interesting star. This star looks familiar. Haven't we been here before? What's going on? What kind of space is this where we keep seeing the same stars again and again? It's easier to explain in a two-dimensional universe than a 3D one. But what would a 2D universe be like? Let's call it flatland. Life in two dimensions has its problems. When two flatlanders want to pass one another, they can't go around each other or to the side as we would, since they can't leave the plane. Our athletic flatlanders must jump over one another to continue on their way. The flatlanders live on the one-dimensional surface of their two-dimensional planet, just as we spacelanders live on the 2D surface of our 3D planet. The flatlanders' planet is orbiting a sun. Their sun is a two-dimensional disk, just as our sun is a three-dimensional ball. Like ours, their sun is just one of many stars in their universe. Let's watch the flatlanders explore their universe. They head straight off into space and are surprised to come across their own sun. Perhaps their universe is a sphere and they took a trip around its equator. Or perhaps it's a cylinder. Or a torus. Each of these surfaces is a possible shape for a two-dimensional universe. Note that we have taken advantage of our three-dimensional space to see something that two-dimensional flatlanders can't see directly. In a similar way, four-dimensional people could draw three-dimensional universes in their space, but that's another video. We three-dimensional people can see them without the fourth dimension. We can visualize 3D spaces using only 3 dimensions for our drawings. We first try to understand a flatlander's universe without the extra dimension. Suppose their universe is a torus. We'll save a copy of it, cut the torus once, and deform it into a cylinder. Cut it again, and open it into a square. This square is a fundamental domain for the flatlander's universe. We now see their universe using only 2 dimensions. The flatlanders can still travel about their universe as before. When looking at a fundamental domain, we must imagine that its edges are glued together. Anything leaving one glued edge returns at the other. The way we glue them determines the shape of the space. It doesn't matter where we put the cuts. We need cuts to draw the fundamental domain, but they don't really exist in the space itself. When our cut passes through the flatlanders, they don't feel a thing. What do the flatlanders see in this universe? Their line of sight travels around the universe, and they see the back of their own spaceship. Like the flatlanders themselves, their line of sight can't leave their 2-dimensional space. They see what appears to be a copy of themselves. Indeed, they see images of themselves in many directions. This tiled picture shows what the flatlanders see and that their universe is boundless. They'll never reach an edge. From the picture of the single fundamental domain, we see that their universe is not infinitely large. It contains only 3 stars and 1 spaceship. It's finite. Neither picture alone gives the full story. By combining these 2 pictures in your mind, you can get a better understanding of the true nature of their space. Now we're ready for 3 dimensions. Take a cubical block of space. We'll use this for our fundamental domain in 3 dimensions, just as we used a square in 2D. We glue the left and right walls. Now the spaceship can travel around this finite universe, passing the same stars again and again. We glue the top and bottom. And finally glue the back to the front. Now the space has no boundary and the ship can travel in any direction. This space is called a 3 torus. Let's ride the spaceship inside the 3 torus. Even though the 3 torus is finite, we have the illusion of flying in an infinite space. There are only 2 stars in this universe, but we see each one over and over. This isn't the only possible shape for space. Before we visit another 3D universe, we'll look at the corresponding 2-dimensional space. Its fundamental domain is again a square. This time we glue the left and right sides with a flip. This surface is called a Möbius strip. When the spaceship takes a trip around, it comes back upside down. The flip makes a difference in the shape of space. A second trip restores it to its original condition. Let's watch the trip again on the original square. Now glue the top and bottom of the square with no flip. What do the Flatlanders see in this space? Looking up, they see the bottom of their own spaceship. Looking forward, they don't see their ship right in front of themselves because of the flip. Their line of sight keeps going across the bottom. When it wraps around a second time, it's flipped again, and they finally see the back of their own ship. The Flatlanders have the illusion of seeing a reverse copy of their universe, followed by a regular one. They see infinitely many images of their universe, half reversed and half not. What if we do this in 3D? 2 pairs of faces connect as in the 3 torus. To make the flip, connect the top of the right face to the bottom of the left face and vice versa. After 1 trip, the spaceship appears mirror reversed. After a second trip, it returns to its original state. Let's see what this space looks like from the inside. As in 2D, we see infinitely many images of our ship. Half are mirror reversed, half are not. When we roll, our reversed images roll in the opposite direction. Life in this space is different than in the 3 torus, where all the copies of the ship move in the same direction, like a flock of birds. We fly this way and see ships in neighboring rows flying in the opposite direction. The mirrored images turn as we do to fly along paths that seem to cross ours, but they can never hit us. That's impossible in this space.